All right, so this is a continuation of 14.2, the second day of it, so the day 4 notes. And the back side of this is all about labeling, okay? Labeling is a way to count the number of ways to put labels on distinct objects. Okay, it's this idea that I'm assigning something to a specific object. Okay? Each object is given exactly one label. Each object given exactly one label. Oops, that's a 1. In other words, this is exactly like number 2, where we were assigning, okay, specifically like number 2, not 3 from the front. Because in number 2, we were assigning people to a label like butterfly or dino or giant. Person to giant, dino, so on and so forth. Okay? Another example would be this one here. I have 15 students volunteering at a senior center. The director needs 8 students to supervise, 3 students to visit with the immobile senior citizens, and 4 students to plan events. In how many ways can jobs be assigned to these 15 students? So you are specifically being assigned a role. So you could do like we had done on the front. You can still do like number 2 on the front, but there's a quicker way. So if you can identify that we are putting labels on specific things, then you can go to this new formula. And the formula for labeling is n factorial over r1 factorial times r2 factorial dot, 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 all the way to however many there are. So we need to know, so this is the formula for labeling. All right? The n stands for the number of distinct objects. Sorry, that's supposed to be t. So in this case, my number of distinct objects would be 15, right? Because there are 15 students. And R stands for the number of items with each label. So in other words, we're going to be labeling 8 students as supervisors, so one of my R's is 8. I'm going to be labeling 3 students to visit, so one of my R's is 3. I'm going to be labeling 4 students to plan, so one of my R's is 4. Okay? The reason this is dot, dot, dot is because I'm just going to put however many there are. If there were 20 different assignments, then I would have to put 20 different numbers underneath. But you have to be careful because this only works, and this is important, it only works with combinations, not permutations. With combinations, not permutations. And you should also realize that this will work for arranging letters from a word. So arranging letters is a combination. Because each letter is a label that you assign. So as soon as I see word, like how many arrangements of these letters are there, I immediately know that it's going to be labeling that I need to do. So example 1 here. This is the same example from up here. So 15 students. I want you to do this one on your own, and we're going to do the other 2 together. So looking at number 2, Tommy, Natalie, Morgan, and Dominic are playing euchre. How many ways are there to give each of them 5 cards from a deck of 24? Well, we've got to be really careful about this problem, because if there's 5 of them, so there are 1, 2, 3, 4 people, and there are 5 cards each. Right? 5 cards to each of them. Well, isn't that only 20 cards that you are using doing that? So you have to realize that there are 4 left at the end. And those 4 left have to be accounted for. They're not being assigned to anyone. So we are taking cards and we're assigning the cards. It's the cards that are being assigned. Cards assigned. So when we talk about the number of distinct objects, there are 24 cards in this deck. So when we think about this, n factorial over r1 factorial times r2 factorial dot 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 rk factorial, right? Well, how many objects do I have? Because n is the total number of objects. We have 24 objects, right? Then 5 of them are being assigned to Tommy. 5 of them are being labeled with Natalie. 5 of them are being labeled with Morgan. 5 of them are being labeled with Dominic. And 4 of them are being left over, so they are assigned to be left at the center that no one has. So now we can just go to our calculator and type this in. So either you need to use the fraction button, or you're going to have to use parentheses. I'm going to use the fraction button if I remember where it is. There we go. So 24 math, remember we go over to probability, factorial over 5 math factorial, 5 math factorial, 5 math factorial, 1, 2, 3, 4, and I've done 3, so another 5 math factorial, and then a 4 factorial. And there's my answer. So it is 1.247 times 10 to the 14th power. Now you could have typed this in without using the fraction button, but remember that these would have to be in parentheses to show that this is the top, then the division bar, then the bottom. All right, so let's look at the next one. How many different arrangements are there for the letters coefficient? So again, this is a letter problem. As soon as I see letters, I know that it's a labeling problem, which means we're doing n factorial over r1 factorial, r2 factorial, so on and so forth. Right? Now the issue is, what am I assigning them? Well, we talked about this at the top. Each letter is a label, right? So C is going to be one of the things I label them with. O is going to be another label. E is another label. F is another label. I already have F, so I don't need that again. I is another label. C we already have, I we have, E we have, N we don't have, so that's another label that it's going to get. And T is another one. So now we have to decide how many things are going to be labeled with C. Well, 1, 2. So there are 2 C's to label with. O's, there's only 1. E, there are 1, 2. F, there are 2. I, there is 1 I, 2 I's. N, there is 1. And T, there is 1. So 2 things will be labeled C, 1 will be O, 2 will be E, 2 will be F, 2 will be I, 1 will be N, and 1 will be T. So my total, because N stands for the total, how many total letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters in total that we're going to be able to choose from. So 11 factorial is my number of elements. And then I have 2 C's that are 2 things labeled with C, 1 with O, 2 with E, 2 with F, 2 with I, 1 with N, 1 with T. So now we're going to have to go ahead and type that in our calculator, and you will end up with 2,494,800 ways, different arrangements for those letters. Now, don't forget that you need to go back and try number 1 on your own. Remember, think about what the labels are. So I was labeling here, Tommy was a label, Natalie was a label, Morgan was a label, and so was Dominic, and then the cards that were left in the middle. So those were my labels, which is why it was 5, 5, 5, 5, because that's how many cards they would get assigned, and then the middle got assigned 4. Here, the things getting assigned were the C, the O, the E, the F, so these were the items, that the ways that we were going to label our labels, and there were that many options for each of those labels. So think about that. What are my labels? How many options are there for each of those labels? And then go ahead and fill it into the labeling format. And we'll go over this tomorrow.